let's solve some problem. Exercise 1.1 problem states as find the domain and range of each function. So 1 to 6. So number one problem is f of x is 1 plus x square. Problem 2, 1 minus square root of x, or 10. F of x is 1 minus square root of x. 3, f of x is square root of 5x plus 10. Number 4 is g of x is square root of x square minus 3x. Number 5, f of t 4 over 3 minus t. Number 6, capital Z of t is 2 over t square minus 16. So number one problem was 1 plus x square. F of x is equal to, we have to find the domain. So domain of f, we know domain is the allowed value of x. So here we see no problem with any real number. So the domain would be minus infinity to plus infinity, and the range of f would be, you can see here the value of x square cannot be negative. So x can be 0. So f of 0 is 1. So the minimum value is 1. So 1 to positive infinity. This is our range. So we just solve the number one problem. What's number 2? Number 2 is f of x equals 1 minus square root of x. So let's solve this. We know inside the square root the value cannot be negative, so x have to be greater than 0. This can be 0 but have to be greater than 0. So allowed value or domain of f is going to be from 0 to positive infinity. We can take 0, but so what about the range? Range of f, if we take f of 1, which is going to be 1 of minus 1, 0, then f of 0 is just 1. F of 4 would be 1 minus 2 or minus 1. So if we take really large number like 100, we should get 1 minus square root of 100, which is 1 minus 10 or minus 9. We see that as we approaches infinity, the value of f of x approaches negative infinity. So the maximum value of f is positive 1. So positive 1, and the minimum value can be as negative as possible, which is negative infinity. So the range of f is negative infinity to 1. Question number 3, given f of x is square root of 5x minus 10. So the allowed value of x would be, we know negative cannot be inside the square root. Negative cannot be inside the square root. So 5x minus 10 has to be bigger than or greater than 0. If we add plus 10 both sides, this gives 10. and if we divide both sides by 5, this gives 2. Domain of f is x greater than 2 to positive infinity. We can take 2. Okay. So what about the range? So let's check some value. So the range would be 5x, square root of 5x minus 10 is for value 2. So f of 2, we see that this is 0. And if we take f of let's say 10, this should give 50 minus 10, which is 40, square root of 40, which is a positive number. Range of f is going to be from 0 to positive infinity. So 0 is included and we can never reach infinity. Okay, let's move on to the next problem. Problem number 4. Problem 4 states g of x square root of x square minus 3x. So we have to find the domain and range of the function g of x is equal to square root of x square minus 3x. X square minus 3x has to be positive. If we factor x minus 3, so product of x and x minus 3 has to be positive. So let's solve for x times x minus 3 is equal to 0. We get x is equal to 0 or x is equal to 3. In number line, if we take value less than 0, then the x time x into x minus 3 would be positive. So we can take any number between negative infinity up to positive 0. If we take any number between 0 and 3, let's say 2, then x 2 times 2 minus 3, which is minus 1, would be negative. So this portion gives less than 0. This portion gives, so this portion gives x square minus 3x greater than 0. This portion gives x square minus 3x less than 0, and this portion of the number line gives x square minus 3x greater than 0. So this region also is allowed. So domain of g of x is minus infinity to 0. 0 can be included because if we put a g of 0, this gives g is equal to 0. So 0 is included. What about 3? So if we put 3 square is 9. 9 minus 9 is 0, also included. So 3 to plus infinity. So this is the domain of this function. We can say that any number, for any number, g of x is always positive. Range of g of x is 0 to positive infinity. Let's do the next problem. Problem number 5. So problem number 5, f of t equals 4 over 3 minus t. So the denominator cannot be 0 because we cannot divide by 0. So 3 minus t not equal 0. So t not equal 3. Domain of f of t would be minus infinity to 3. 3 is excluded here. 3 to plus infinity. What about the range? So we can see that f of t can never become 0. So range of f of t is minus infinity to 0 union 0 to plus infinity. So let's do number 6. Problem number 6. We have to find the domain and range of 2 over t square minus 16. So the denominator cannot be 0. T square minus 16 not equal 0. So t cannot be plus or minus 4. So domain of g of t, or allowed value of t, minus infinity to minus 4. We cannot take minus 4 union minus 4 to plus 4 union 4 to plus infinity. What about the range? So our function was g of t 2 over t square minus 16. domain. So I have to calculate the range. Here we can see we have three intervals from minus infinity to -4, -4 to +4, and 4 to infinity. So interval 1, 2, and 3. For interval 1, t less than -4. Interval 2, t is in between -4 and +4. And interval 3, t is greater than 4. So if t is less than -4, t square would be always positive. So this would be always greater than or 16. So t square minus 16 would be positive or greater than 0. So if we divide it 2 over a positive number like t square minus 16, this should also be greater than 0. So here for this interval we get g of t is greater than 0. For second interval, t is in between -4 and +4. So t square would be less than +16, but t square cannot be negative, so it has to be positive, so greater than 0. It can be 0, so equals here. Subtract 16 in the east side, we get -16 t square minus 16 less than 0. We can see that t square minus 16 is less than 0 here. So if we take the reciprocal, the inequality sign should flip. -1 over 16, 1 over t square minus 16. So from the interval 2, we get g of t is less than or equal -1 over 8. What about interval 3? Interval 3 was t is greater than 4, t square would be greater than 16. So t square minus 16 would be positive. So 2 over t square minus 16 would be also positive. So g of t is positive. So from interval 1, we get g of t is greater than 0. G of t is greater than 0. And from interval 2, we get g of t is less than -1 over 8. And from interval 3, we get g of t is greater than 0. Combine and write range of g of t. So here we can see that g of t can be less than -1 over 8. So minus infinity to up to -1 over 8. -1 over 8 is included union. So g of 2 also is greater than 0. So 0, positive infinity. So range of g of t is from minus infinity up to -1 over 8 union 0 to positive infinity. This range can be verified in another way. So the given function of g of t was 2 over t square minus 16. So we know that domain of g inverse of t is equal to the range of g of t. Find the inverse function of g of t, let y is equal to t over t square minus 16 and solve for t. So t square minus 16 would be 2 over y, and t square would be 2 over y plus 16. So t is square root of 2 over y plus 16. So g inverse of t, we get square root of 1 over t plus 16. So let's find the domain of g inverse of t. So here we can see the denominator cannot be 0, so t cannot be 0. Also the square root has to be positive, so the term 1 over t plus 16 has to be greater or equal to 0. But previously we seen that this term cannot be 0, so 1 over t plus 16 has to be positive we have to solve this inequality. If t, so 1 over t is greater than minus 16. If t is positive, then this should not change the sign. If we take the reciprocal, t would be 1 over 16. We made a mistake. Here would be 2. Now let me correct. If t is positive, then this should not change the sign. So t over 2 minus 1 over 16, or t greater than minus 1 over 8. If t is less than 0, we know for inequality, if a is greater than b, then 1 over a is greater than 1 over b. But if both sides are negative, like minus a is greater than minus b, then if we take the reciprocal, so minus 1 over a, then minus 1 over b would be less, like this. So if we take the reciprocal here, t over 2, this should flip the inequality. So minus 1 over 16, or t is less than 1 over. So domain of g inverse of t would be minus 1 to 1 over minus 1 over 8. Can we take 1 over 8 minus 1 over 8? So let's calculate g of minus 1 over g inverse of minus 1 over 8 is square root of 2 over minus 1 over 8 plus 16, which is minus 16 plus 16 is 0. So we can take, and this is also be greater than 0. So 0 to positive infinity. So from this we can write range of g of t is going to be minus infinity to, like that.